Good evening, good morning, and good afternoon if you're watching. Welcome to my show. My name is Fani Reinders, and I've decided to ad hoc do another stream this morning. At this stage, it is Wednesday. It's almost 6 o'clock, and I thought, well, it's a good time to go. So let's see what we can be building today. Today, I don't have any plan. We can see I've got some stuff that I want to show that I found, and let's get the show going. So, good morning again for the guys that's watching the stream and just tuned in. Like I said, it's a lovely Wednesday morning here in the Netherlands. How are you guys doing? I see the people starting to get into the chat room. Welcome. Give me a shout out to tell me where you are from, so that we can have a nice conversation on code.net, Blazor, anything that you might think is relevant. I almost am a Twitch affiliate, so it would be great to get to that point. Have enough followers on Twitch to become a Twitch affiliate. Apparently you have to be 50 followers, and I've reached my following count, which is cool. It's that one of my goals, and some other things that you also need to do, like stream more than 7 different days, I think. Stream for a bunch of hours, have some people chat in the chat room, views, all that kind of things help also reach another point. But that's the main reason that I'm not on Twitch, is to become an affiliate. But it's cool to be an affiliate because it just opens up to maybe join other live streamers in teams, for instance, and it also opens up more more capabilities in your account. But I'm here to teach code, right? That's part of my mission on my profile. I'm gonna actually change my screen. I found this cool website called MatBlazor, and I'm actually trying to figure out how I'm gonna show this properly, because I'm kind of in a way here. MatBlazor, so it's material design components for Blazor and Razor components. So do note that Blazor and Razor components are different things. So Blazor runs in the browser, and it can also run on the server side. If it runs in the browser, it means that it runs on WebAssembly. So just going back for the folks that don't know what Blazor means. If you go to blazor.net, this is a good example. So it's interactive web UI with C#. So you have your HTML that you define, and also within your HTML you define your C# functions, and then it compiles. It's assembly. It compiles and it can run on WebAssembly. Now, WebAssembly is a new thing. It's a modern thing that allows runtimes to be run in the browser itself. So, with other words, your DLLs and your basically your libraries run in the browser. There's no server-side calls. They could be, but there is no call to the server side. It's self-contained, almost like, I dare to say, a Silverlight or a Flash thing, but just way better, you know. But it doesn't stop there. Blazor, and this is still in preview, the WebAssembly part. So you can host this on client side or server side. So if you host this on client side, that's fine. That works. But you can also choose to host it on server side. Where is an example? But hosting on server side doesn't change anything, right? It just changes the hosting model of it. And there are a bunch of examples online that you can actually go to the documentation to see what's happening here. So we can go to the hosting models. So this is the client side I was talking about earlier. You can host this on. Give me one sec. You can host this on the client side, so it's in the browser with a UI thread and WebAssembly runs there. Or you can do a server-side host. So how that works is with the magic of SignalR. So it runs on the server side, and I presume it's on the same kind of mechanism, but it sort of pushes. It knows what the client has, and it keeps state of what the client has, and all the changes are diffed, and only the changes get pushed through with the magic of SignalR. SignalR is another technology, .NET based, that is using server-side push mechanism to get changes to the browser. So whenever something changes, the server calculates it and pushes it through to the client, giving you that SPA feeling. But it's actually, you don't need WebAssembly to run. Now this launches in this month during .NET Conf on September 23rd, I believe, part of .NET Core 3, which is quite cool. Pros and cons for both. Like for client side, you would need WebAssembly, and it has an impact on how you architect your solution, because you can imagine if you open up the page. I can actually show you let's go to blazor.net again, and maybe there's an example here somewhere. Let's go to Blazor example, see if we can find one. Here we go, hello world. So this is a typical Blazor page. So it's a single page application. And how do you know it's a single page application? Well, I normally do the highlight test. So the highlight test is you highlight something on the screen, which means it's highlighted. So normally when you refresh, the highlight goes away, right? So the highlight test is if you highlight something on the screen like a header there, maybe zoom in a tilt, and when you click around, okay, now that goes away. That fails the highlight test. But normally when you click around, it will stay there. So is this even a SPA? I have no idea. Where's them? Yes, okay. So let's go. If I hit refresh on this thing, it's interesting. On the right, you will see what happens. So it fetches a bunch of CSS that's expected, a bunch of JavaScript that's expected, but then you see this mono WASM. Maybe just let me zoom in a bit. How do I zoom in? Oh, what's that? What was that? This is from the Power Toys. How cool is that? Oh, that's cool. So if I zoom in a tilt here, this mono WASM is a WebAssembly format thingy. So that's basically the mono runtime that has been compiled specifically for WebAssembly. So mono runtime is the mono framework is basically a kind of a spin-off or a flavor of .NET that they've compiled, and it's pretty much .NET, right? So it's a cross-plat .NET flavor, and used that cross-plat mono flavor, and they compiled it to a WebAssembly specific version, MonoWASM. So when this application downloads, the first thing it does, it obviously fetches the artifacts, but then this, where's my screen is now stuck for some reason. So this Mono.js gets activated, which downloads the MonoWASM, right? So now MonoWASM runs in the browser, or MonoWASM runs on top of WebAssembly, and then WebAssembly says, okay, I'm going to run this runtime. What do I need to start? So now, because we have the runtime effectively .NET, we can throw in any DLL that's .NET based. So as you can see here on the list, all the DLLs that it needs, it's downloaded on the client side. So you can imagine, when you architect your application, do not put in business logic, I would say, or even proprietary logic in here, because it will be downloaded, and you could use tools like Reflector or whatever to get the code essentially if security measures aren't taken. So but this is still cool, because if I go back to my network tab, just maybe highlight this again, clear. So it's been downloaded now, right? So when I move around, see what happens. Nothing gets downloaded except for the stuff that's actually needed. So there we just download the weather JSON, but if I go back there again, it downloads it again. But you can probably cache that. It's already cached from disk. Well, the point is that it doesn't download all those DLLs again, right? So that's a plus. So the point is that if you architect this, make your UI, you will still have your UI in the backend, but make your UI including all the view models, all the screens, and all that kind of stuff can be C#, and it all can be part of a DLL, or even one big DLL that's optimized, because .NET Core 3 has this functionality of tree shaking, I believe, where you can compile, and it only compiles the things needed for your application. So let me see if I can find an example. I don't know if this is an example. I'm just like pointing to someone's blog, Alan Chua. I hope I say his name correct. No, this is not it. Let me see if I can find a different example. I know Damien Edwards has blogged about this before. Let's go see the release notes. Okay, that's the preview. I'm actually looking for the release notes. This one, right? Goes back to the same page. Okay, change this release. Alright, so let's see. Features. This is specific, so let's see if I believe it has been introduced into, I think, preview 7 or 6, maybe let's go there and see. So release notes. Okay, there's Docker and optimize. There we go. So optimize your .NET Core apps with ready-to-run images. Okay, so it's got that. And so this is just as I understand it, this ready-to-run is just a mechanism to do a better job to JIT your application and have it start up faster. So assembly linking, I think this is the one I was talking about, yes. So assembly linking, let's just read through it. The .NET Core SDK comes with a tool that can reduce the size of your apps by analyzing the intermediate language and trimming unused assemblies. So with .NET Core, it has always been possible to self-publish self-contained apps, but it will include the whole runtime, so the whole thing, which makes it a big as download, right? So with IL Linker, you can choose, if you add this in your CS proj, you can choose, it will actually analyze your dependencies, and it will link everything together, and it will exclude the stuff that's not needed. So i.e., if you're not using certain packages like Newtonsoft JSON, for instance, it won't include that into download. So it will be a much smaller publish. So here it says the publish include a subset of framework libraries depending on what application code calls. So it's not just looking at NuGet packages. It's looking at the actual code your application calls, and if it touches on certain libraries, it will only download those into, if you're using Blazor, into the Blazor WebAssembly into the client. So this is an example going from 68 megs to 28 megs. It's about 50% savings, which is quite substantial, especially when you're using stuff like Blazor, you know. So that's something cool. So you kind of have to architect your application so that it's still two parts, right? So, and it still calls into a backend server. So let's say, for instance, this weather forecast has a special business logic that you don't want to expose to the client. You still can call this, but you call this with normal C#, right? So you can call it with the HTTP client. It will still call to the API that you have at the backend, and it will still work 100% correct. I just want to say hello to the guys that just joined us in the viewing panel. Thank you very much for watching. Welcome. Yeah, do reach out if you have any questions. My name is Fani Renderers, and I'm trying to sort of today. This is an ad hoc stream. I started today to think about what am I going to be streaming, and I was like, let's take a step back and let's maybe explain Blazor a bit, and then if there's time still left, I'm only going to be around an hour, so not so long. Then I'm going to be taking a look at our project called the SDNcast website, which is our podcast website that I've been building for a couple of weeks in this technology called Blazor. But nevertheless, I'm showing now the client-side hosting model. If you flip out to the server-side hosting model, then that's the technology that I use for the podcast. Rue George, welcome, Rue George. Thank you very much for the greet there. Hope you are well. Hello, hello, hello.